cold a little bit, so apologize for an occasional cough. As Dinah said, I'm Mark Angelo, and I really do have the honor and pleasure of leading the Boeing teams to support the C-17, KC-135, KC-46, and the KC-10. Excuse me. I am really excited to be here. It's actually been a little bit of old home week. I've had a wonderful opportunity to catch up with some friends that over the last several years we've had to do this virtually, and it's just been extremely exciting, and hopefully you're all getting the same out of this great event. Would like to thank LOA for all the hard work in putting this together. It's no small feat to coordinate all the activities across the days that we're here, and just a big thanks to them for bringing government and industry and academia together to really talk about accelerating change and sustaining dominance, an incredibly relevant topic, and I think it's one that we're all up for the challenge for. And actually, my last and dearest and sincerest thanks to our active and retired veterans that are out in the audience and here with us. The work that you do every day, the leadership and the partnership, the amazing things that you do for our nation, thank you very much. You know, every day counts, and so when you're out there, make every day matter. I think that's an important thing for all of us to recognize. Focusing on warfighter outcomes is what really inspires Boeing. As you know, the Department of Defense has really called on industry to bring digital engineering and rapidly deliver engineering, warfighter capabilities to you, the customers. Back in 2020, General Brown issued a report from the strategic challenges ahead and said this: if we fail to adapt to the changes in the strategic environment, a large and growing body of evidence suggests that we risk losing a great power competition. Otherwise said, accelerate change or lose. In addition, much has been said and written recently about contested logistics. And today, unfortunately, we're seeing much of those attributes play out on the world stage. Boeing's been responding to this call as we brought decades of digital engineering and expertise to create transformative capabilities to our customers. We're really taking decades worth of investments to redefine the latest capabilities. These capabilities could be delivered to the warfighter in greater speed, greater flexibility, and bring the value while applying the right analytics to meet the evolving mission as well as sustaining requirements. Our missions today are to deliver a digitally advanced, efficiently produced, and intellectually supported aircraft. Boeing's first century probably could be defined on what we built, and I think the second century is going to be defined on how we build it and how we, more importantly, sustain it. So I'd like to share with you just a brief glimpse of some of the things that are going on with Boeing. So if you would roll the video, please. So what we've tried to share, just that brief glimpse inside Boeing, are some of the digital capabilities that we're bringing to you, the customers. You know, the T-7A Red Hawk is proof that this digital approach works. Engineers applied model-based engineering and advanced manufacturing and testing techniques, and we took from the computer screen to first flight in 36 months. 36 months. Even before building the first 2 physical production representative aircraft, full-scale interactive 3-dimensional virtual models enabled engineers to assess the performance configuration, to model supportability and maintenance opportunities, as well as ergonomical aspects of the assembly process. Interaction with this virtual product allowed us to influence design changes early in the design cycle in order to maximize efficiency through the entire chain. The result was a digitally enabled, digitally native platform. Once fielded, the T7 digital twin now informs the ecosystem of what it needs rather than the system defining what the aircraft needs. So think about that. Each aircraft now, as a digitally native platform, can inform the maintenance team, the operators, what it needs. So the focus on these warfighter outcomes through the data-driven products creates a paradigm shift now such that we're driving readiness across the spectrum. It is really revolutionizing the way we maintain and we modernize customer fleets through this data-driven product support. Traditionally, as I said, the system tells the aircraft what it needs and when it needs us. And that does create less predictive reliability, less predictive readiness. It drives higher costs, as we know. Excuse me. I think as this slide shows, and I'll advance it. Excuse me. T7. So this is a representation of the T7 model-based engineering. And as you can see, the arrows point out from the aircraft. The aircraft now is able to inform the ecosystem, the supplier support. We can actually push data to our suppliers to build information to where kit proofing is no longer required. Tech data moves seamlessly across the ecosystem. We're able to push data to our training teams and to our maintenance teams. Drives efficiency and, as I said, less cost. We see the value of this that is created to the warfighter through these open architectures and these digital applications. And we're committed to the DoD's vision for this rapid deployment of new software-centric capabilities to unlock the interoperability, the predictable maintenance, and the data sharing. But what I'd like to say is it's not just applicable to newly produced platforms. Many of us service and support legacy aircraft. This digital concept really does apply to our legacy fleets. When we apply digital capabilities, we enable a legacy platform. On the C-17, for example, we've developed a tool. It's a data reasoner. We've developed more than 25,000 algorithms that lie within that data reasoner. It's built on a container-based open architecture. It is your data as a customer. We interpret that data. We provide the input back to you to help inform maintenance crews. The data reasoner really does create a digitally enabled platform. And the results of these algorithms tell the operators what the jet needs. I think the most exciting thing is, as we continue to evolve this journey, the maintainers themselves are coming back to us with great ideas and great innovations of how we could continually evolve the algorithms that we're developing. Those capabilities get rewritten into algorithms and get applied back to future jets. Again, your data in and your data out. So where's the proof? Over the last 4 years, we've outfitted 33 aircraft with these data reasoners. We've captured more than 140,000 flight hours. We've provided 12,000 maintenance recommendations. We've mitigated more than 28,000 man hours, mitigated 17,000 NMC hours, avoided 200 plus engine runs, and more importantly, saved over 4.5 million pounds of fuel. That's real money, that's real savings, that's accelerating operations, and that's reducing turn times. So let me share with you a brief example of what you might see from the output of this data reasoner. So we had a recent situation where a pilot was transatlantic flight coming back to the States. And when he landed, he talked to the maintenance crew and said, really had to do a number of fuel transfers during this flight, more than normal. Can you guys take a look at this? So fortunately, this aircraft was outfitted with one of our data reasoners. You can see the plots on the bottom right. One of those does not look like the others. Those are the bleed valves for our engines. Immediately you can see that the third one down there represents an issue. So we addressed the bleed valve. It happened to be okay as the checkout was completed. So that allowed us then to push on to the fuel pump. We changed the fuel pump, that corrected the issue, but in examining the fuel pump and interrogating the data, we found that excessively worn bearings. Now, bearings don't give you an indicator, a fault indicator. So this would have stayed on aircraft for years. We were actually pushing 400 pounds a flight hour of excess fuel across this engine. So we changed this, fixed this one particular airplane. But what we did now that we had this data signature, we were able to go into the fleet where we've seen similar situations on other aircrafts and apply this data signature to 10 other aircrafts, replaced those fuel pumps, and in examination, they all had the same bearing wear. So using that as a predictive data set, we were able to change out 10 additional fuel pumps, again, saving thousands and thousands of pounds of excess fuel. This data analytics isn't just applicable to the field maintenance teams. We've recently run a pilot program where we've installed these devices on jets that are heading into heavy maintenance. As many of you know, if you're a C-17 maintenance personnel, that our jets fly into Warner Robins or San Antonio to perform maintenance tasks. And so we've outfitted these data reasoners 90 days in advance of heavy maintenance. And our data analysts are looking at major subsystem performance, overall flight performance. And we're taking that data and we're talking to the ALC, we're talking to the MROs weekly on what the data is telling us. And as a result, we're providing data into the depots in order for them to pre-plan. What this has done is moved data and information to allow unscheduled maintenance to move to scheduled maintenance. So we've piloted this on 3 platforms. All 3 successfully have identified issues that would have been discovered in the depot, caused disruption. But with the pre-planning, it's allowed us to put the right people with the right skills, the right parts, and actually put it into the right schedule in order for us to be effective in the depots. Excuse me. The last thing I'd say on the data reasoner is because we capture all the data, it isn't just for the maintenance community. But we also are applying the information and providing it to our operational community for both safety and training impacts. We've seen some scenarios where pilots have performed tasks that perhaps are a little outside the window of what the specifications are articulating. And in those situations, we're able to feed that back and change the curriculum to ensure that those are emphasized in the training to ensure pilot and crew safety. But data analytics isn't just for the maintenance community. Recently, we've had situations where we've had to push personnel downrange or to our customers in an agile environment to put the expertise where it's needed. Because of COVID, we were unable to do that. And as you can see in the upper left-hand side, some maintenance operators outfitted with some AR/VR goggles and some maintainers back in Boeing. So what we did was we took a AR/VR capability built on a Microsoft HoloLens and a Boeing application that was built with industry protocols and an open architecture hardware agnostic solution. And we pushed that out to our customer in the Royal Australian Air Force. Now, through an authentication pool that keeps that secure network connected, we did some initial training with the pilot. We set them up with some data, and we launched into performing a critical mission. The way it was set up was the mechanic would see the critical task. We had a SME in Charleston and we had a SME in McCord who could see what the mechanic saw. Those SMEs could pull up tech data into their computers at their desk, and in the field of view of the mechanic, he could also see that data. And we also have a stylus pen capability where the SMEs that are sitting at their desk can highlight certain aspects of the critical task to ensure that the mechanic understands the technique. So this mechanic had never performed this task, and after just a few hours of training and with the connectivity back through the secure network was able to do that. We've subsequently done that with 3 additional customers, and we've also now outfitted our MRO facility with that same capability to allow our mechanics to reach back to our engineers across the United States as we work through critical issues and critical challenges on the platform. And then lastly, we've recently deployed that with some of our international crews and the flying crew chiefs to take down range to begin testing in a downrange location. From a contested logistics environment, we need to be agile. We're not going to be able to deploy particular skills in every location. And we feel like we need these capabilities in order to take the skills, disperse them, and allow them to force multiply across using the technology. Because you can see what the operator sees, it really does allow us to deliver first-time quality through the secure reachback. I think I'd like to just close by saying a couple of things. You know, digitally advanced capability, we know, is what's required when we produce new aircrafts. It's a given. But I think more importantly, to sustain aircraft, we have to be innovative in the way we enable our legacy platforms in order to inform the systems to increase readiness and drive down cost. Boeing is committed to partnering with all of you to unlock these capabilities for the full potential of our logistics teams now and for in the future. I thank you and make every day count.